So we're talking about angles and parallel lines cut by a transversal today. So an angle that is standing alone is formed by two rays. So a ray is a part of a line that has an end point on one side and then goes forever on the other side. So like this one, this ray BA, it stops at B, but it goes forever to the right. So that's a ray. So you can name an angle three different ways. You can name it by its vertex, and so the vertex is where those two rays are meeting. So in this one, that would be B. So you put a little angle sign and then a B. And so we can say this is angle B. Or if they have numbers on the inside, so like this one has a 1, we could name it angle 1. But the most common way that they're going to name them is by all 3 points. So when you name it by 3 points, you always want the vertex to be in the middle. So we could say ABC, or we could say CBA, and it would be talking about the same angle. Okay? So we could say angle ABC, or CBA. Okay, so you can switch those orders as long as you keep the vertex in the middle. Okay, so A, B, C, C, B, A. Any questions on naming them? Alright, let's look at this picture here. So we have this picture. We have 4 angles meeting here. 1, 2, 3, and 4. So we want to name angle 1 in a different way. So this is angle 1. In the middle I have angle S. Would I want to call it angle S? No, because why? If I say angle S, do I know which of these 4 angles I'm talking about? No, because they're all angle S. They all have the same vertex. So then if I want to name this angle 1, good. I can say QST. Very good. Or what else could I call it? Good. TSQ. Good. So either way is fine, as long as you have the S as your middle letter. Questions? Alright, so next we want to look at RSQ. So RSQ is this one. How else could I name that one? Yeah, so I could just say angle 4. How else could I name it? Good, QSR. Questions? So now we want to name the sides of angle 3. So angle 3 is right here. So one side is this side, and then the other one is this one. So when you name a ray or a line segment or a line, you use the 2 points that are on that line. So in this first one we have SU, or you could say US, don't matter. And then since it's a ray, we can just put a little ray over it. And what would be my other side? SR, good. Good. Or again, you can say RS, don't matter. Questions? Okay, so there are some special angle pairs that we're going to talk about. So vertical angles is something that we use a ton. And so vertical angles are formed by intersecting lines. Okay. So when you have intersecting lines like these over here, you have 4 angles that are formed. And so vertical angles are across from each other. Okay, so our vertical angles here would be 1 and 3, and then 2 and 4. Okay, so they're always across from each other. Well, if I look at 1 and 3, do they look like they're equal? Yeah. How about 2 and 4? Yeah. So vertical angles are always equal, or they're always congruent. Okay. So that's something that you use a lot when we're going to be proving stuff here in the next couple of days. So it's called a theorem, and that's just kind of like a rule. This is another way to say a rule. And that's vertical angles are congruent. And congruent just means equal. And so a symbol that means congruent is an equal sign with a squiggly on top. So if you see it equal with a squiggly, that means congruent. And we'll talk more about symbols tomorrow. So on a picture, to show congruence, they use like little marks. So if 1 and 3 are congruent, they would have a mark like this. And then 2 and 4 are congruent, so they would have 2 marks. Okay. Questions so far? So then our next relationship is a linear pair. So a linear pair are 2 adjacent angles, and so adjacent means that they're beside of each other. Okay, so they share a side, and they form a straight line. Does anybody remember how many degrees are in a straight line? Good. So they make 180 degrees. Good. So in this one, we have a bunch of different linear pairs. So if I'm looking at this line here, 1 and 4 form that line. Also 2 and 3 form that line. So they're a linear pair. If we're looking at this one, 1 and 2 and 3 and 4 also form that line. So those are linear pairs. So anytime they're beside of each other and they're making a straight line. Okay. So our next thing is called the angle addition postulate. And it just says that when you add one angle to another one, that it makes the big angle. So in this one, I've got the m. So this little m means measure. So you're not just saying the angle, you're saying the measure of the angle in degrees. So like if it's 25 degrees or whatever. So it's the measure of the angle. So it says the measure of PQS. So PQS is this side. And it says that plus the measure of RQS, so this side, equals, so if I add the small angle to this small angle, then I'm going to get the bigger angle. So PQR. So let's say the top angle was 20, this bottom one was 30, add them together, so the whole thing would be 50. Okay. So you're just adding the two angles together. Okay. So let's look at one. So if we look at number 1, let's say we want to find the measure of the angle BAD. So what would be the measure of that angle? BAD. 65. How you know? Yeah, you just add them. So you just say 30 plus 35 is 65 degrees. Good. Question. So let's look at number 2. So number 2, it gives me this angle. It has that little square thing in it. What does that mean? Good. So when you have this little square, that little box, that means it equals 90 degrees. Okay. So in this one, we want to solve for y. Well, I have that this bottom part is y. This top part is 3y minus 25, but I know the whole thing equals 90. So then what we want to do is add our two smaller ones together and set it equal to the whole thing. So y plus 3y minus 10 equals 90. Okay? So the small angle versus the bigger one equals the whole thing. Any questions on that? So then what should I do to solve it? Good. Combine like terms. So y plus 3y gives me 4y minus 10 equals 90. Then what? Add 10. So 4y equals 100. Then what? Good. So y equals? Good. Questions? Alright, let's look at 3. So on number 3, I have these two angles that are across from each other. Well, what did we say these are called? Well, yes. So the lines are intersecting, but the angles are called vertical angles. And what did we say that vertical angles are? Equal to each other. So on this one, if we wanted to solve for x, we just set these equal to each other. And so then you can solve it however you like to solve it. I always like to get my x's over there on the left, so I'm going to subtract that 4x. So x minus 4x gives me negative 3. So then what should I do to solve it? Minus 16. So negative 3x equals negative 21. And divide. So we get, good. So then sometimes it might say not just what does x equal, but what does the angle equal. So then you might want to take the 7 and plug it back in. So if we plugged it in, 7 plus 16. So then our angle would equal 23 degrees. So if it says